Okay, in our previous lessons, we had talked about energy, work, and power, and that has led us up to where we are today, and that is machines and mechanical advantage. So, what am I expecting out of you by the end of this class? I am going to expect you to give the purpose of machines, explain the three ways that work is made easier by machines, and then be able to calculate something called actual mechanical advantage when you know how much work has gone into and comes out of a machine. Now, in order to understand that, we need to review a couple terms. First, a force, any push or pull. We measure forces in newtons. And then we need to talk again or review quickly work. Work can be calculated by taking the force times the distance that the force is applied, and we get joules. Okay, so what is a machine? A machine is any device that makes our work easier. What are the ways that it makes our work easier? The reason we usually use machines is because we want to change the amount of force that we have to exert. Okay, so the machine will multiply our force that we put in, making us move objects that we could not normally move. Another thing that it may do, it may help us reduce the distance that we have to apply the force, or it will increase the distance at which an object moves with the help of the machine. And finally, it will change the direction at which we apply force. Sometimes because of certain situations, it's impossible for us to apply a force in the proper direction, so we set up or use a machine that will allow us to accomplish what we need to do. So by changing the direction of the force, we can get the task completed. Basically, when we think of mechanical advantage, we think of that first way that work is made easier, and that is that it multiplies the force. It takes the force that we put into the machine, multiplies it, and the machine puts out even more force than what we put in. Now, there are two different types of mechanical advantage. There is ideal mechanical advantage, which happens or occurs in a perfect world if there was no friction. And then there's real-world mechanical advantage, actual mechanical advantage, because we know we deal with friction in the everyday world. Now, there are three ways we're going to look about calculating this actual mechanical advantage, which is going to be our focus for today. We can simply look at the change in forces. As we say here, that we are looking for a machine that multiplies the force. And if we know how much it multiplies the force, we know its mechanical advantage. In other words, we take the force that the machine puts out and compare it to the force that we put into the machine, and that will give us its mechanical advantage. Another way to compare them is to compare the work that's put in and the work that comes out. Okay. And to do that, in many cases, we have to know force and distance. What is the force coming out of the machine compared to its distance? And the force going in the machine compared to distance. Okay, so those last two kind of go hand in hand, since we already learned about what work is and how to calculate it. So, work input versus work output should be pretty simple to understand. Work input, what do you do to the machine? And work output, what does the machine do? Okay, obviously we try to get machines that allow us to put in less force and the machine put out more force. That's the best case scenario. If that happens, we get a mechanical advantage of greater than 1. But sometimes that is not the case. Sometimes we use a machine that will give us a mechanical advantage of 1. In this case, there is no advantage as far as force goes. We have to put in as much force as we get out, but we would use a machine that has an MA equal to 1 if we wanted to change the direction the force is acting. Okay, that would be a good reason. Sometimes we will even go to using machines that have a mechanical advantage of less than 1. That means that work is a little harder because we're having to apply more force than the machine creates, but again, we would do this if we absolutely needed to change the direction that the force is being applied. Now, let's just do some examples of here how we can calculate mechanical advantage. Mechanical advantage in this case is we're using a lever, and that lever can do 500 newtons of, or apply 500 newtons of force whenever 75 newtons is applied to the other end. So in this case, we are simply going to compare the force out to the force in. We're going to get 500 newtons of force out if we apply 75 newtons. So we do the simple division problem, 500 divided by 75. You get 6.66 repeating. We'll round that to 6.7. Something I do want to point out here is that the newtons cancel out. So when we calculate mechanical advantage, there are no units. Again, no units for mechanical advantage. Okay. We're simply looking at how much the force in was multiplied by the machine. Here's a second type of machine. It's a pulley, and we'll talk more about these simple machines later on. In this case, we're going to use a pulley to lift a 5,000 Newton piano, so obviously the machine has to be able to pull that piano up with 5,000 Newton force. We know this particular pulley gives us a mechanical advantage of 20. So what you're being asked here to do is to figure out how hard are you going to have to pull in the rope? How much work are you going to have to do on the rope? What a force are you going to have to apply? So what we are finding in this particular case is the force in. Okay, to find force in, you just take the force that the pulley is putting out and divide it by its mechanical advantage. In this case, we know that the force out has to be equal to the weight of the piano, so 5,000 newtons. We know that this machine, this pulley, will multiply our input force by 20. That's its mechanical advantage, so we simply divide that by 20, and we get 250 newtons. And again, since we're measuring force, we do need to include a unit. And our unit in this case is newtons, because you can see in the problem there, the newtons do not cancel out. Okay, as we move on, we're going to take another angle. And in this case, how much force would a screwdriver put out? So in other words, what is the force out? If we apply 5 newtons and have a mechanical, and the screwdriver gives us a mechanical advantage of 4. So we are trying to find the force out. How much force did we apply to the screw? In this case, it's a simple multiplication of mechanical advantage times the force applied to the screwdriver. So in the case, mechanical advantage was 4. We applied 5 newtons of force, or we twisted the screwdriver with 5 newtons of force. In turn, the screwdriver is going to apply 20 newtons of force to the screw. Okay, this is why you use a screwdriver. If you try to screw a screw in with just your hand, you're probably not going to get it done. But as soon as you apply that screwdriver, you gain a mechanical advantage and you're able to get the screw in. So those are examples of how we can find mechanical advantage, force in, and force out. Now in this case, we're going to look at it from a different angle, and we're going to talk a little bit more, instead of forces, we're going to talk about work, which is force times distance. In this case, our lever lifts a 200 Newton object 5 meters. You have to apply 50 newtons of force over 10 meters. So we are going to find the advantage of using that lever. So in this case, we got to use MA equals FD out compared to FD in. Well, the force out was 200 newtons. The distance the object moved was 5 meters. We applied 50 newtons of force over 10 meters. Okay, so if you do the math here, 200 times 5 is 1,000. 50 times 10 is 500. And we get a mechanical advantage of 2. Okay, we get a mechanical advantage of 2. So it made our work twice as easy. Again, we're back to our screwdriver. In this case, the screwdriver, you're going to turn it 0.2 meters. With 5 newtons of force, the screwdriver applies 10 newtons to a screw and moves it 0.4 meters. What is the mechanical advantage? Again, we know forces and distance, so we're just going to do those work out versus work in. So we take the work out first, that is the 10 newtons applied to the screw, and the screw in turn moves 0.4 meters. We put in 5 newtons of force over 0.2 meters. So simply again, we're going to take 10 times 0.4, and we're going to get 4 newton meters, or 4 joules. And we multiply 5 times 0.2, and that's going to give us 1 joule. So 4 joules divided by 1 joule, joules cancel out. It is a mechanical advantage of 4. So again, this is doing, we're comparing, instead of comparing the force out and force in, we're comparing the work out and work in. You can do it either way. Now I'm going to do a problem in which 200 newtons and move a rope pulley 6 meters. The pulley lifts a 2,000 newtons piano 3 meters off the ground. Again, when it's mechanical advantage, just like we did before, we're comparing work. Okay, so if we look at what the pulley does compared to what we do, the pulley lifts with 2,000 newtons of force for 3 meters. You, in turn, have to pull with 200 newtons of force over twice that distance, or 6 meters. Okay, so 2,000 times 3 happens to be 6,000. 6,200 times 6 is 1,200. And again, those are both in joules. Joules cancel out. We get a mechanical advantage of 5. Okay, so there's examples how a lever, screwdriver, and pulley make our work easier. Okay, that is where I am going to stop today. In the module that I have created, there is a worksheet. Okay, there is a worksheet. You are going to need to download that out of the module. Okay, and you will need to complete that worksheet. Make sure you read where it says show all your work. You must include all the work to get credit. You must also make sure that your units are correct. If you're calculating mechanical advantage, there is no units. Okay, if you're calculating force, you're going to measure in newtons. Okay, again, distance is in meters. Work is in joules. So again, make sure all of your units are correct. And this is what your worksheet will look like. Again, emphasize the part here in red, show all your work. So use the rest of the day to do that. There is a submission box in assignments. If you want to work it out on your own piece of paper and turn that into me after Thanksgiving break, that will be fine also. I do not have any printed pages for any of you. So have a great day. Also have a great Thanksgiving break.